Alright guys, so today we're going to talk about logarithmic functions as opposed to exponential functions. So I want to start off with us remembering how to find the inverse of a function. So I'm going to remind you how to find the inverse, and then I want you to try A and B. So do you guys remember how to find the inverse of a function algebraically? I mean, we know that it's reflected across the line y equals x. So to find the inverse, remember that we are going to switch x and y and resolve. Okay, so I want you to try to do that in A, switch x and y and resolve. I'm going to give you a couple minutes to do that. Alright, so let's take about 30 seconds and talk about that with your partner, and then I'll show you on the board. Alright, so let's talk about this. So our first one, I'm always going to switch my f of x to y. So y equals 2x minus 5. And then if we switch our x and y and resolve, so x equals 2y minus 5. Minus 5. Alright, then add 5, so x plus 5 equals 2y. And then our last step is to divide by 2 on both sides. So you can write that x plus y over 2, or you can write it 1/2 x plus 5/2. Okay? Alright, so then let's talk about this other one because it's very similar. First step's being the same. So y equals 2x squared minus 5. Add 5, so y plus 5 is 2x squared. Divide by 2. I still see people taking the square root before you're dividing. So, oops, backtrack. I didn't switch the x and the y. Alright, so x equals 2y squared minus 5. Add 5. 2y squared. Divide by 2. Alright, so we get y squared is x plus 5 over 2. And then square rooting both sides, y equals, and I still see people doing this too, forgetting our plus or minus, square root x plus 5 over 2. Okay, so now let's look at the function that we looked at yesterday, because this is the interesting one. If I were to use the same steps that I've been using to find the inverse of 4 to the x, that's y equals 4 to the x power. if I switch x and y, I get x equals 4 to the y power. The question is how to get y out of the exponent. Okay, so here is where we introduce a new function to you all. And I'm sure you remember this from Algebra 2, but it's the logarithmic function. Okay, so here's the formal definition of log. It says if y equals b to the x, then log base b of y equals x. Okay, b has to be greater than 0, can't equal 1, because 1 to the anything, if we put a 1 in right here, you just get 1 the whole time. Okay, and then the domain of these guys is y has to be bigger than 0. Our range is y has to be bigger than 0. Our domain is all rows. Okay, so let's talk about some of these problems. We're going to change each statement to logarithmic or exponential. So I want to show you a little trick I saw. Here's the little trick. If you're going from, this is exponent form, see we have something to a power equals a number. To change it to logarithmic form, we're actually going to draw an L. So here's our L. L, L. So how does that help us? Well, that's the order that they're written in the logs. That's log base E of 9 equals B. Okay, so when you see exponent to log, you're going to draw the L. Now, if you go backwards, if we go log to exponent, we're going to draw an E for exponent. So here's the E. So here's what that looks like in exponent form. 3 to the C equals 5. Okay, so draw the L or draw the E, depending on which way you're going. So I want you to try C and D with your partner right now. Suggestion on both of these is to rewrite them to where they look like this. So a to the 4th equals 24. And then flip this guy around. Log base E of B equals -3. And now rewrite it. Alright, so let's look at these. So if we draw our L, we have log base A of 24 equals 4. Okay, and then on our other one over here, we want to draw our E to go to exponent form. E to the -3 equals B. So some of your homework is like that, just moving between the two forms. Okay, here's part 2 of your homework. And that is using now what we know about logs to find exact values. So no calculator. Do not go to your calculator on this one. Okay. So here's the easiest way to think about this. And we're going to look at this first column together. And then I'm going to have you try the other ones. Okay. So this is the question that you're asking yourself. 2 to the what power is 16? That's what I'm asking. That's what log is asking. It's 2 to the what power is 16. So 2 to the what is 16? 2 to the 4th. So log base 2 of 16 is 4. Okay? So let's try this one, this 5 one. This one's a little bit more complicated, and you're going to need that in the ones that I've hidden with the black box right now. So the question I'm asking is 5 to the what power is 25 square root 5? Okay, so if you see, I've got some 25s and 5s over here, I got a 5 over here. I need to be able to compare them because this is not a straight like the one up above. Oh, I know 2 to the 4th is 16. I don't know 5 to the what is this, okay? So we're going to do a little bit of work on the right-hand side. 25 I can rewrite as 5 squared, okay? The square root of 5 I can rewrite as 5 to the 1/2, okay? Now we should know what we do with exponents that look like this. We add them together. So 5 to the what is 5 to the 2 plus 1/2, or 5 over 2. Okay? So you're going to need that. You're going to have to change these guys to where they have the same base, okay? Over here underneath here, and I'm going to reveal that in a minute. All right, last one that I'm going to do with you, and then I want you to try some. 4 to the what power is 0? Okay? Now I want you to think back to what we did yesterday. When we were doing exponents, if you remember, our asymptotes were at what? At x equals 0. Okay? We can never have an exponential that reaches 0. This one is undefined. Okay? Log is not defined at 0. Alright? Okay, I'm going to give you about 3 minutes to try these 3 over here. Or 4. Okay, so let's look at a couple of these. Let's look at our first one up here. So we have 3 to the what power is 1 over 27. Okay, so we have to remember a couple of things. One, we have to remember that when things are in the denominator of a fraction, that means a negative exponent. But we're really dealing with 27 to the negative 1. Okay, and then I've got to know how 3 and 27 are related. So 3 to the what equals, well, 27 is 3 to the third, but then I still have that negative 1. So 3 to the what power is 3 to the negative 3. Okay? This next one's super easy. You should have gotten this one. 3 to the what power is 9? And that answer is 2. Okay? Alright, 5 and 6 are tricky. So let's talk through those. 36 to the what power is 216? Okay, so first off, you kind of have to know how 36 and 216 are related. And 36 is 6 squared. And 216 is 6 to the third. So this is really the equation that you're solving. Let me underline it for you. 2 to the what is 3. 2 times some box has to equal 3. If we divide by 2 on both sides, we get that that is 3 over 2. Okay, so 36 to the 3 over 2 equals 216. All right, let's look at this last one. So you got to remember a bunch of things in this last one. First, you have to remember what a square root looks like in exponent form. Okay, and you have to deal with the negative exponents. All right, so the right-hand side, I hope that is pretty easy. That's 7 to the negative 2. Okay, the left-hand side, 343 is 7 to the third. Okay. Okay. But it's also to the 1/2, and that's the question that we're asking. Is the square root of 343 to the what power is 1 over 49? Okay, so this is a lot of stuff. Let's combine some stuff. 3 times 1/2 is 3 over 2. Okay, equals 7 to the negative 2. So really the question I'm asking is 3 over 2 times what gives me negative 2? Okay, so you can think about that as multiplying by the reciprocal on both sides. So what power? Negative 4 over 3. Okay, so those are the trickiest kind, I think. 5 and 6 are the trickiest kind of what you're going to see tonight. Now let me introduce you to the 2 log buttons that are actually on your calculator. They kind of have a special name. Okay, the first one, whoops, too far. The first one is the natural log, which is the LN button. And you know how we were drawing the E and drawing the log? This is actually natural log of E. Okay, they don't put the E there. It's kind of like when you're talking about the square root, we don't put the 2 there, but that's assumed to be there. It's the same thing here. And then when you're talking about the common log, this is log base 10, even though they don't put it there. These are the 2 buttons that are on your calculator. Okay, so if you look at our questions that we have down right here, pull that up a little bit, rewrite as an exponent. So remember this is log base 10, and remember when we're going to exponent form, we're drawing the E. So 10 to the 4th power equals x. Okay, and so 10 to the 4th power is 10,000. Okay, and then when we look at natural log, I'm going to flip this one around so we can use our little trick. And we have to remember that this is base E. Okay, and then when we draw our E, we have E to the 7th power equals x. Okay, again, another button on your calculator. All right, and then when we look at evaluating, again, remember this is base E. So remember the question we asked ourselves on the previous page. E to the what power is 1 over the square root of E. So E to the what power equals, remember if it's in the basement, it's negative. If it's downstairs, it's negative. The square root means 1/2. Okay, so our answer is negative 1/2. All right, now I want you to play with your buttons on your calculator. So grab your calculator and I want you to evaluate the following, all 4 of these, and we're gonna go 3 decimal places on these. All right, try that, and once you have rounded to 3 decimal places, check with your partner. Alright, so I hope you're able to evaluate these on your calculator pretty easily. So I'm going to tell you what I got. For a natural log of 20, I got 2.996. Okay, for log of 5, I got 0.699. And then for the last two, I hope that you got the same answer. The natural log of 0 is undefined because remember our domain has to be bigger than 0. And the natural log of -2 is also undefined. Okay, the log cannot have negatives assigned to it. All right. So let's look at the last thing for today, which is graphing. Okay, so here's how I want you to graph. This is how I graph. This is what I have found the easiest way to graph, and it's to think about inverses, okay? Because, all right, give myself some space here. All right, we're going to go back and think about inverses, which is what we talked about at the very beginning, okay? Think about your inverse. So if we graph f of x equals 2 to the x, we need to remember or recall that the inverse of that is log base 2 of x. So let's build a t-chart for the first one and then talk about how the t-charts are related. So we did this t-chart yesterday, -1, 0, 1, 2 to the -1. 2 to the -1 is 1/2. 2 to the 0 is 1, 2 to the 1 is 2. Okay, so over here on my chart I have -1, 1/2, 0, 1, 1, 2. Okay, remember from yesterday that the exponential function looks something like that. Okay, now I want you to remember back at the beginning of the year when we talked about inverses, remember what we did at the beginning of this lesson. Even when you find the inverse, you switch the x and y. So the t-chart for log base 2 of x is literally this t-chart just with x and y flipped over. So it's it's 1/2, I keep wanting to say -1/2, 1/2, -1, 1, 0, 2, 1. Okay, so 1/2, -1, 1, 0, and 2, 1. Okay, and so my graph looks like this. Remember that when we graph the inverses, they are symmetric to the line y equals x. And that's that line that runs from corner to corner on our t-chart. Sorry, that looks terrible. But you can see how these guys are, it's a reflection across that line. Okay, so when I graph these guys, I always graph this t-chart first because I can do that in my head, then I flip it over. Okay, so I'm going to skip ahead to the graphing ones and then we'll come back and talk about domain and range. Alright, so let's look at this first one. This is y equals log base 8 of x minus 5 plus 5. So I want you to do the quick t-chart for y equals 8 to the x, because you should be able to do that from yesterday in your head. So 8 to the -1 is 1/8, 8 to the 0 is 1, 8 to the 1 is 8. Okay, now to our t-chart, the one we're actually graphing, we're going to flip that over. So 1/8, -1, 1, 0, 8, 1. Okay, that is the simple part. Now we have to do the transformations. Okay, so remember that when we see a -5, really what is that doing? That's really doing a +5 to all of our x values. And then when we see a +5 outside, that one stays the same. We're doing a +5 to all of our y values. Okay, so now we just have to graph it. 1/8 plus 5 is 5 1/8. 1, 2, 3, 4, 5, and a little bit past. And then we're up 4. 1, 2, 3, 4. Okay, so that's 5 1/8 and 4. My next point is 6, 5. So 6, 5. Sorry, I'm having trouble making these points with my pen. And then we have 13, 6. So way out here, up 6. So my graph looks like this. Now we need to remember that it doesn't just do that it curves and goes down, because what is happening at 5? There's that asymptote at 5. Okay? So I'm going to jump start you on the next one, and then I want you to see if you can finish the t-chart. So what is the inverse of natural log? It's y equals e to the x. Okay, so I want you to build the regular t-chart for this one, and yes, you can go to your calculator for e. Alright, so the t-chart that you should build for the e, I got, when I plugged in -1, I got 0.37, and I'm just estimating. 0 is 1, because 0 is always 1, and then 2.72. Okay? So then what do these negative signs do? Well, this negative sign goes on my x. So negative, negative, negative. Okay, this negative sign, oops, hold on, pause. We need to flip our t-chart over. I didn't flip it over first. Let's flip it over, then put the negative signs on there. All right, 0.37, -1, 1, 0, 2.72, 1. Now put the negatives. All right, so negative, 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 okay, and then what does this one do? Negative, 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 which of course 0 can't be negative. All right, so take a minute and graph that for me. Okay, so we have, let's see if I can get my pen to work a little bit better. I'm going to use my clicky pen. So negative 0.37, and then we have positive 1, so about right here. And then we have negative 1, 0, so here. And then we have negative 2.72, so a little bit past 2, and negative 1. So my graph looks something like this. Sorry, this is, I'm drawing on my screen. Okay, so it's not perfect. All right, again, you can look at Desmos. You are going to have to do a little bit, just very, very simple graphing on the non-calculator part of your test, okay? All right, let's go back and talk about this one last page, and then I'm done talking. Let's talk about domain and range, okay? When we talked about exponentials yesterday, I hope you remembered about the domain, that the domain was all reals. We can plug any x into an exponential, negative, 0, positive. But our range was our graph lived above 0. Remember that 0 was an asymptote. Okay? So guess what? Not only do inverses switch the x and y, not only are they guys inverses, they actually, the domain and the range switch. So for logs, our x has to be bigger than 0, and our range is all reals. Okay, so let's look at the domains of this. Okay, so if we look at our first one, we have to say that x plus 3 has to be bigger than 0. So what does x have to be bigger than? Negative 3. There's my domain. Okay, so that means my asymptote, let's think about graphing this for just a second. My asymptote has now moved from being at 0 to x equals negative 3. Okay, all right, I want you to have a little bit of discussion with your partner about this next one. Absolute value of 1 has to be bigger than 0. All right, so go. All right, so let's do a quick little talk about this one, okay? So I hope you remember that when we're dealing with absolute value and inequalities that we have to rewrite it. So x minus 1 has to be less than, usually when we flip the sign we make this negative, but there's no such thing as negative 0. So x minus 1 has to be less than 0, but x minus 1 also has to be bigger than 0. So let's think about that. X is less than 1, but x is also bigger than 1. So let's put that on a number line. So here's our number line. Here's 1. We know we have an open dot. Okay? So in order for me to be positive, I have to be less than 1 and greater than 1. So what does that tell me? That x cannot be 1. 1 is the only spot that does not work on that graph. You should check out this graph on Desmos. It's pretty interesting to look at. So, all right, I think that is all I have to say today. So our assignment is going to be 4.2. You have the rest of the class period to work on that. If you will remember, we will have a homework quiz on 4.1 on Wednesday. All right, you guys have a good rest of your day, and I will see you on Wednesday.